Exercise 1.2, question 6. Explain why 7 times 11 times 13 plus 13 and this entire expression are composite numbers. So we have to explain why these are composite. There's no doubt that they are composite. So think about it. Read a question so that you get information from it wherever possible. So here the information I got was that these numbers are already composite. I just have to explain why. Now, here's a page from the book to help you understand what composite numbers really are. So, composite numbers are those that are expressed as a product of primes. These prime numbers do not have to be distinct. For example, I choose the prime number 2 and I just multiply 2 with itself. So, this is a product of primes. This is the number 4. So, 4 is a composite number. These prime numbers could also be different. So suppose I have 2 times 3, then 6 is what I'll get. That is a composite number. It doesn't have to be just two prime numbers. I could have any number of prime numbers. Suppose this, then I will get 30, and that is also a composite number. Basically, the idea is that every composite number can be expressed as a product of primes. And then it goes on to say this in other words: if we multiply two or more prime numbers, you saw 2 here in this and more here in the third case, if we multiply 2 or more prime numbers, allowing them to repeat as many times as we wish, it's totally our choice. Just how we did repeat in this first one and did not in these other two, we can produce composite numbers. So both of them, both these points are saying the same thing, that composite numbers are nothing but product of prime numbers. So here, this first one that I have, the first numerical expression that I have, how will I be able to explain that this is composite? I have to be able to express this as a product of prime numbers. The whole thing should be expressed as a product. Right now what you see is a plus sign here. Yes, the other two are multiplication signs, but we have to do something about this third sign as well. Now, now see what we can do. Observe that there is this number 13 in both of these terms. I can call this whole thing here one term, and this is another term. Whenever there's a plus or a minus sign, that is what creates a new term. Now, I can take 13 common from both of these. So what I'll have inside from term number 1 is 7 times 11. And from this second term, I will have just one left because I've taken the entire 13 out. And there will be a plus sign in between. So taking this 13 means 13 times this. Let me just write that. Perfect. Now see what we can do with this. You can say this is 13 times, what is 7 times 11? That is 77. Then 77 plus 1 is 78. Now you would say 78 is not a prime number because I know it is divisible by 2. A prime number is something which is divisible by only 1 and itself, nothing else at all. While here 78 has 1 itself and 2, so it's not a prime number. But what you can do is you can express 78 as a product of prime factors. So you can prime factorize 78 using the factor tree method or any other method that you are comfortable with. Now when you do that, this is what you will get. So this will be 2 times 3 times 13. When you write the 13s together, then you will have 2 times 3 times 13 squared. So you could express this first expression, this one here, let's call it part A, you could express it as a product of prime numbers or product of primes. And so this expression is definitely composite. Now, this entire discussion was based on the definition of composite numbers that we get from the book. But you don't really have to do so much here. You can really be done with your solution at this very first step only when you take 13 common. Let me tell you how, but I'll have to clear some space first. Alright, the moment you expressed your expression as this, you could see that it has 13 as a factor, right? 13 is visible here as a factor. Whatever is inside the 78 that we saw later and then broke it further was not needed. This 13 here tells us that the expression that we are working with has a factor other than 1 and itself. 1 and itself, I know it's other than that. Why? Because 13 is definitely not equal to 1. It's different from 1, as well as the fact that 13 is not equal to this entire expression. This is way more than that. This is this 7 times 11 times 13 plus 13. It's definitely way more than that. So the expression that I have, let me just say expression, is not equal to 13 and it's not 1 either. So 13 is a factor that it has, that this expression has, other than 1 and itself. That means it is not a prime number, because what did you learn about prime numbers? Prime numbers only have two factors, 1 and itself. Every prime number has just two factors, 1 and itself. So here the moment you find one more factor, it's other than 1 in itself, you can be sure that it is not prime. So if it is not prime, then that means it is composite. So you can be sure of this being composite without doing all of this extra work here. Now when we do this second expression, we will just use this logic. Okay, so this is the second expression. Let's just call it B. Again, my goal will be to see whether it has any other factor other than 1 and itself, because as you know, having just 1 in itself means that the number is prime. Okay, so when I write this expression down, my first term is this huge product 7, 6, 5, 4, 3, 2, 1. So it's this product of all of these numbers, these 7 numbers, plus the second term is 5. Now again, if you look closely, you will see that there is one number that you can take common from both of these expressions, from both of these terms. So this is going to be 5 times. What will you be left with from the first term? The others, 7, 6, 4, 3, 2, and 1, and from here you will just be left with 1. Now no matter what this expression is, no matter what the value of this is, you can see that you have one factor. This expression has one factor 5, which is definitely other than what? 1 and the expression itself. It's not 1, it's not itself. So it is something else, and that means it is not prime again, and the moment you know it's not prime, it is composite. Now there is just one exception to this rule. What exception I'm talking about? I am saying that suppose there is this number 1. Now the number 1 is not prime. Why? Because it has just one factor, while prime numbers have to have these two factors, 1 and itself. But 1 is not prime does not mean that it is composite. Why? Because 1 is not composite either. This is a special number. It's not prime, it's not composite. Remember the rule, prime numbers have to have two factors, while composite numbers have to have greater than two factors. Now the number 1 does not have either of these, because this one here has just one factor.